Hello everyone. In the last few videos, we'll try to understand how image will be found in case of concave mirror. Now we'll try to understand how image will going to form in case of convex mirrors and what are its advantages and all. We'll try to learn. See, in case of convex mirror means what happen? Convex mirror, you need to place object in front of the mirror. In the convex mirror, outer surface, what is that inner surface? No, the inner surface is reflecting. This is the reflecting, sorry, outer surface is reflecting and inner surface is coated. This is being coated and outer surface is reflecting. When rays will falls on this like this, the rays will try to diverge outward. They will go outward direction. Okay, this is why it will go outward direction, because reflecting portion is outwards. It's in plane mirror only this much, in concave inside only, but in convex mirror you can see large reflecting area. It is outward, bending is outward, so large reflecting area. So you will get the reflected rays will diverge outward direction. So in that condition, only two possibilities are there. We can see center of curvature and pole. See, in case of concave mirror, if you extend this like a center circle, you can get a center of curvature at the C in front of the mirror. But in case of this mirror, you will get center of curvature at exactly at the behind the mirror. You will get center of curvature, and similarly focus also you will get behind the mirror. So focus and center of curvature and pole will be except on the surface. Center of curvature and pole will be outside. In this type of condition, how image will going to form, we'll try to understand. Yeah, this is the figures of concave mirror. We need to understand convex mirror, right? Just next image. Yeah, this is the image formed by concave mirror. This is a ray diagram to represent image formed by concave mirror. So how this one is, see, this is what is a shaded given. This area is coated. Okay, this is coated, and this surface, the black line indicates that is reflecting. When object is at infinity, object when you place object at infinity, you will get this dotted line indicates object rays in lines are coming from infinity. When object is at infinity, when image will be found at focus. Image will be found at focus. See here, it is actually the reflected rays are not meeting. Where reflected rays are, they will going to diverge outward. But they appears to coming from not from infinity. They appears to coming from where? Coming from the focus behind the mirror. So that is what it is called as virtual. Okay, children, this is called as a virtual, and this is virtual image. No, that is always erect. It is upright. It won't be inverted. It will be erect and upright. So this erect image and virtual image, because in the same side of the mirror, okay, in front of the mirror will form, that is what we call real, but back side of the mirror it will form, that is what we call virtual, and erect image will form when object is at infinity. Image will be found at focus. So only try to understand position of object. Okay, position of object at infinity. Image position is at focus. And the next condition, just okay. Yeah, this is the next condition. When you place your object at anywhere between from infinity to pole, okay, from infinity means at focus will form. When you place infinite to pole, in between infinite to pole, when an object is between infinity and pole, if you place somewhere in front of the mirror, that time you will get object. Okay, you will get image. Where you will get image? You will get image at between the pole and the focus. You will get. Okay, we will get the image between pole and focus. You will get. Here is the image. You can see image is small and size. Object size, height of the object is this one, but height of the image is very small. That is what advantage of convex mirrors. The main advantage of convex mirrors is you will get a more field of view. See, reflected ray, suppose the ray will come entirely at this point, no, you can see reflected ray will go like this. It is having more field of view up to here to here. You can see this much area in front, what is happening, so much area we're going to cover in the small amount of this. So that's why the larger size objects will get a smaller size. Object is larger, but image will get a smaller size, but field of view is more. So second condition is, first condition, when object and image, when object at infinity, image will be found at focus. And when object is between infinite to anywhere, we can call anywhere between infinite to pole, if you place object image, will be found between pole and focus. This is a pole, okay, pole and focus, this is a focus. Between pole and focus, image will form. That characteristics of the image, you see, it will be back of the mirror, it will forming. So when it is formed back of the mirror, it is again virtual, and it is, see, upright. How we are standing, same like this standing, it is like this image, and image is also like this. So it is erect image will be found, okay, image will be virtual, erect, and it is diminished. In a concave mirror, you see the last condition. When you place very closer to the mirror, that condition you see erect, virtual, erect and enlarged size. You see virtual, erect and enlarged size. But here what you get, virtual, erect and diminished size you get. Okay, these are the two differences of concave and convex mirror. So this is a ray diagrams in case of convex mirror. I hope this is clear to everyone. If you have still any doubt regarding this, please comment. You can see this picture also for clarity. Yes, just a second. Okay, here you can see image formed by convex mirror. When you place object somewhere, anywhere between in front of a mirror, not at infinity, anywhere infinity to pole, you can place object, image will form behind the mirror. Okay, this is the front face, this is the back face of the mirror you will get. Okay, this is the image you will get. Where, see, you can see how the ray diagram is going to run. No? One ray which will take parallel to the principal axis. This is the principal axis. Parallel, this is the principal axis. You've taken parallelly the ray to the principal axis. It will diverge outward, but it is appears to coming from focus. See, this ray is appears to coming from focus, and the next ray, which is passing through the center of curvature, or appears to pass through the center of curvature. After reflection, it will retraces its same path. It will appears to go back to same path. That means the two rays you can see here, the rays are meeting. One ray from focus, it is going through the focus, and one ray which is through the center of curvature. Both are meeting. That means when two rays meet, what you will get? You will get image. Okay, image. That is diminished image. Diminished image, that means smaller size compared to object, and it is virtual, and it is upright or erect. You will get. Clear, children? These are the few properties of image formed by concave mirror. I hope this is clear. In the next video, we'll try to understand what are the advantages or uses of convex mirrors, and try to understand also differences between concave and convex mirrors, how it will be, they will be differ in their function. Thank you all.